So, hello friends, welcome to my YouTube channel. So, today's topic is uh, Kubernetes architecture. Okay, it is contain two nodes. Okay, so first one is our control plane. Okay, so these are the different terminologies used for the master node. Okay, so basically it is the handling the control of the Kubernetes. Okay, and the second one is worker node handles your traffic and control plane, and the control node handles your control plane. Okay, so with considering Amazon AWS service, okay, so we will be seeing the EKS cluster. Okay, EKS, elastic cluster node. Okay, so control node is basically the main heart of the Kubernetes. Okay, so in the control node we have different components. Okay, so the first one is APIs. Pod has to run on which node? Okay, then there is a kubelet, is the interface between API server and Docker engine or worker node, right? What is Docker engine? Next part is Docker engine, right? It takes the info from kubelet, kubelet and run the container engine, and it will create pod. Okay, and the last is controller. Okay, so what is tool? Okay, to run your Kubernetes command. So this provides you the environment for running Kubernetes command kubectl apply. Okay, so let's say if you have any sample pod file. Okay, sample pod YAML file. So let's say this sample sample pod file. Okay, so in this is kind is pod. Okay, and this pod will create the application will create the pod for the nginx application, right? Image nginx we are using. Okay, okay, so okay, so let's say this is our pod. Okay, let's change the font to some. Okay, so when you run your kubectl apply command, right? So the request first will go to the API server. The first request will go to the API servers. Okay, so API server is work like a medium between your request, that is client side request, and the execution. Okay, request will first come to the API server, and then it manages where to send, to scheduler, to etcd, or to controller. Okay, so it manages where to send that request. Okay, so it is like a brain of Kubernetes. Okay, request will come by client and processed by API server. So the API server will communicate to its CD and take one form of uh, its CD, and same for scheduler also and control manager. So if its CD wants to communicate with scheduler, so its CD want to communicate with scheduler, it has to go via API server. Okay, so and let's say if controller wants to communicate with its CD, it has to go via API server. So API server is the heart of the control node. Okay, so we'll make the connections here. Okay, it will also communicate with scheduler and controller. Okay, so whenever you apply a YAML file, okay, so this is our one sample YAML file to create one pod. So when you apply the YAML file with the kubectl apply command, the pod will be created. Okay, and that pod will be deployed on the uh, worker node. Okay, so I will create worker node here. Okay, so before that, first we'll understand what API server, its CD, scheduler, and controller job is. Okay, so when you interact with Kubernetes cluster using kubectl command line interface, you are actually communicating with the master API server component. The API server is the only Kubernetes component that connects its CD. All other components must go through the API server to work with the cluster state. Okay, so now API server is uh, we have understand. Okay, so now what we'll do is we'll come to the etcd. What etcd does? Okay, so it's etcd. Okay, etcd is a distributed consistent key value store used for configuration management, service discovery, and coordinating distributed work. So it is like just a database. Okay, so where your pod information, okay, which pod will be created, that pod information will be stored in the database called etcd. When it comes to the Kubernetes, etcd reliably stores the configuration data of the Kubernetes cluster. Okay, so cluster is nothing but control node and the worker node. Okay, representing the state of the cluster, what node exists in the cluster, what pod should be running, which nodes they are running on, and a whole lot more at any given point of time. So it is the configuration data for the cluster as well as pod also. Okay, so if any, let's say, pod is deleted from one node, okay, so again pod is created on same node. Okay, so that information given by the etcd. If fresh pod is there, brand new pod is there, then in that case it will give the null response to the API server. Okay, so first request will come to the API server, and then API server will send the request to the etcd to whether to check that this pod is new or it is already there was scheduled on the other node. Okay, so this is the communication between the API server and the etcd. So if pod is deleted from node, etcd will give information to the API server. Will check before this pod was already running or just now it was deleted node configuration service. So configuration will be given by etcd to API server. Okay, so this is the both way communication. Okay, so this is the both way communication. Okay, okay, so this is about the etcd. Okay, so if pod is deleted, let's say from node, etcd will give that information back to the API server that will check before this pod was already running on which node and just now it is deleted node. Okay, so it it will give the information to the API server. Okay, so then API server will inform to the scheduler. So the node was running on node 1, let's say node 1. Okay, is it okay to schedule will so is it okay to schedule on that node only? So that strategy will be decided by the scheduler. So if node 1 is having capacity to deploy that node deploy that pod once again, then it will scheduler will give the go ahead for the that for that pod to deploy on that node 1. But if there is any challenge, will have means if there is any challenge, scheduler will give clearance to land on it on node 2 also. Okay, so depending on the situation, so API will take this info from the scheduler whether to deploy it on node 1 and node 2 based on the condition, and then API server will forward it to the worker node. Okay, yes, that you can create on worker node. That component is called kubelet. Okay, so we will see now the what is worker node is. Okay, so let's draw one worker node. Okay, so this is my worker node. Okay, this is my worker node, and this is my kubelet. Okay, so API server will communicate with kubelet. Okay, so control node to worker node communication will go through via this API server to kubelet only. Okay, when API server gives information to kubelet, kubelet will take it and run the container engine. Okay, so uh, means till now, okay, so first process was like, okay, so first was here one, right? Then next was what? Next is what? This was second process, right? Then this was the third step, right? And then this is the our fourth step. Okay, so API server will now have the all the information where to schedule that pod, okay, on which node, on this worker node or on another workload. So this information which which is having the API server, okay. So API server will forward that information to kubelet. Okay. So when API server gives this information to kubelet, kubelet will take it and run the one container engine. Here pod will create. Okay, so we have the Docker engine also. So this is my Docker engine. Okay, so Docker engine is nothing but it is the Docker engine container. It is the runtime environment for this Kubernetes. Okay, so it will inform the kubelet will inform the Docker engine and container to run the pod. Okay, so when kubelet will give the signal to create one pod. Okay, so one pod will be created. Okay, let's say this is our pod. So let's say this pod is created, right? Okay, so this pod is created. Okay, this pod is created, but this pod is created with some application, and we need to give the access of this application inside the pod to the public. Okay, so which node will give that? Which component will give that? There is a one another component is called kube proxy. Okay, so this is kube proxy. Okay, so this kube proxy will give the, it is like a networking service. Okay, it will give the access to the people, that is the public. Okay, okay, so any image. Okay, print screen. Okay, so okay, so this will give the service. Okay, this is the service. Okay, okay, so oh, okay, sorry for this. Oh, okay, so anyone take one image. Okay, okay, so we will give the service to these users. Okay, so people like these can access the application through this service. Okay, service is by where we can give the public access to the application inside the pod. Okay, so how is the flow? Let's say kubectl, first request is from the kubectl applied to the API server. kubectl writes to the API server, right? Then API server validates the request and persists it to the etcd. Okay, then etcd notifies back to the API server. Okay, whatever the information etcd have. Okay, then API server invokes the scheduler. Okay, this scheduler decides where to run that pod on which node and return that information to the API server. Okay, this information API server passes to the etcd. Okay, and etcd will save that information. Then etcd gives notification back to the API server, right? Then API server, that is the control node, initiates a communication with the worker node. Okay, API server invokes the kubelet in the corresponding worker node. Okay, kubelet talk to the Docker engine container. Kubelet talks to the Docker daemon using API over Docker socket to create the container. Okay, so this. When kubelet contacts this Docker engine container, then it will create one pod. Then kubelet updates the pod status to the API server. Okay, so whatever the pod status, kubelet will notify back to the API server, and this API server persists this new state in the etcd. Okay, so this is the access part. Okay, this is the access part, service part. Okay, so in short, we can write here like in every, okay, in every statement, like what API server done is the API server. What it done? It is the interface between client, client and cluster, Kubernetes cluster. Okay, this is API server. Okay, then next is etcd. Just change the color. Etcd. It is a database which stores configuration information in the form of key value store. Okay, etcd. Then there is a scheduler. It will maintain the desired state and actual state. So what do we mean by this statement? So we have seen that we have sample pod creation file. Okay, so in this file we have specified that there should be one pod should be created with the image of nginx application, right? So one pod will be created of nginx application and it should be run. Okay, so this is the desired state. Okay, so controller, and when this pod will be created at here, right, by following all this process, then it should match the whatever the expected state, whatever the desired state is of the pod. So controller does that job. Okay, so it will maintain the, it will check for the whether this pod has been created with the desired state or not, and what is its actual state. So it will maintain the track of these states. So controller takes care of that thing. It will maintain the desired state and actual state, and if it is not the desired state, it will convey to the API server. Okay, API server will take the action accordingly then, how to treat that pod and how to get it back into the desired state only. Okay, so uh, this is the about the Kubernetes architecture. Okay, I hope it is clear to you. Okay, so we can see the now uh, practical of installation. Okay, so let's say close this. Okay, so I have one Kubernetes installation. Okay, so we need to have the EKS setup. Okay, I need to have AWS EKS setup and the EKS CTL setup. Okay, so two setup we should have. One is the kubectl setup, this one, and one is the EKS-CTL setup. Okay, so kubectl is the our client from which we will execute our Kubernetes commands. Okay, and EKS-CTL is the cluster that will provision our nodes. Okay, so we have seen our nodes, that is control node and the worker node. Okay, so that combination will be taken care by the EKS-CTL, and this kubectl will provide the environment to run your Kubernetes commands. Okay, so just we will install this kubectl and eksctl. Okay, so first we will install. Okay, so I have already created this test server. Okay, so we'll just connect. Okay, okay, so this is the kubectl package. Okay, just go to the sudo su hyphen. Okay, okay, it will download the kubectl package. Okay, so it has downloaded. Then we will give it, sorry, then we will give the executing permission for that, right? Okay, then we will move this kubectl to the user local bin. Okay, okay, and we can check now the kubectl version. Okay, okay, so client version is okay, tradition command. So this is the client version, right? V1.19.6. Okay, so we have successfully installed the kubectl tool, right? Then we need to set up the eksctl also. We need to download and extract this eksctl package. Okay, so this is the command. Okay, version. Okay, so this is the version 0208. Okay, sorry. Okay, so this is about the tool installation. Okay, but now we need to create the cluster also, right? So this is the command for the create cluster. So we can give this eksctl create cluster and we'll give the region name, node type, node minimum, how much nodes you want, 2 or 4, and the zone is availability zone. Okay, so this is the sample one, and it will take about 15 minutes to create the EKS cluster. Okay, so you need to have patience for that to run. Okay, so let's execute this. Let's try to execute. Okay, sorry. Okay, here we can give like our name also, Pratik. Okay, okay. So what this error is checking AWS STS. Okay, so we should have the role here because EKS is another service and the EC2 is another service. So in order to have EC2 the access of the EKS service, so EC2 should have the role permission of the EKS service to the EC2. Okay, so EKS permission should belong to the EC2, that then and then only this service will be communicating. So EC2 will be communicating to the EKS after only by applying the role with this EKS permission. Okay, so for this we need to attach the role with the EKS permission. Okay, So just go to the action and go to the security and modify IAM role and give the admin role like this EC2 AKS. Okay, so this role I have already created. Okay, I will just show you here. So in this role, I am having the administrator permissions. Okay, so if you see these roles, EC2 AKS, right? So in this role, I am having permission. It is loading. Okay, so I am having administrator access for this role, and this role we are attaching to the EC2 instance. Okay, it is taking some time. So see here is the administrator access for this role. Okay, and this role we are attaching to the EC2 instance. Okay, so just attach update IAM role. Okay, so role has been attached to the EC2 instance. Now try to execute that command. Okay, so it has started the running. So it will take around 10 to 15 minutes in order to create this cluster. Okay, so we'll have to wait for that much of the time. Okay, so please bear with me. So this is the delete command. Okay, once you have created the cluster, you can delete by this command. Okay, and the nodes. Okay, so you will be checking the nodes by this command. Okay, kubectl get nodes, because kubectl client we have already installed and eksctl already installed. So this command creates your cluster. So this, okay, so one more thing. See, I am in US East 1 region. Okay, so I am in US East 1 region. But if you observe, I am creating my cluster in AP South 1. Okay, so this is the just environment for the this is the jump host for the creation of the cluster. Okay, so my actual cluster will be created in the AP South 1. Okay, so you need to check in the AP South 1. So I will open the another tab for this EKS, and here I need to select the AP South 1 region. Okay, AP South 1, where it is, this one. Okay, so in these AP South 1, I will be creating my cluster. Okay, so see, this Pratik cluster is creating in the APE South 1. So it is just creating. So I am executing my commands from the US East region. Okay, so this is just the environment. Okay, actual cluster will not be running here. You can see the cluster is getting created here, but actually it is getting created because you have given the AP South 1. Okay, so why we do this? That because your kubectl client is installed in one region, and your cluster is installed in another region to load balance your uh, resources. So you should not have the, means, we will, by ensuring this isolation, we are ensuring that there is no load on the resources in one particular region, and your EKS cluster will not have the load of this kubectl and eksctl. So both are separate. So this will be easy for the workloads to get executed, right? So this is the reason, means it is recommended to create your cluster in another region to have the isolation of the environment. Okay, so it is just creating. Okay, we'll have to wait. So this cluster is Okay, so everyone is cost, means everyone has added charges. Okay, so don't means if you run your cluster and keep it like for several hours, so it will be a chargeable. Okay, so it is very heavy in the charge, so you need to take care accordingly. Just for the trying means for the practice purpose, I am saying. Okay, so I hope you are this very much clear with the Kubernetes architecture concept. Okay, so service, there are we have seen the three service. Okay, node port, load balancer, and one is the cluster IP. So this kube proxy will take care of this, giving the service to the user. Okay, so it is still executing. Okay, so you can see that this cloud formation stack is getting created. Okay, so the cloud formation is responsible for creating your resources. Okay, so EKS is the managed service of the Kubernetes. Okay, so in when you are creating the cluster inside that behind, I means beneath that, the AWS provider is taking care of the creation of the resources. Okay, through this cloud formation stack, you don't need to take care of those things. Okay, because it is a managed service of the AWS, the EKS is. Okay, so behind running your cluster, these much commands are getting created. This cloud formation stack is getting created. Okay, it is responsible for creation of the resources, this cloud formation stack. Okay, it is still creating. So once this installation is complete of the cluster, okay, we'll try to deploy one node. Okay, okay, so it is still running. Let's check. Okay, so we can see the status is active now. Okay, but in the background it is already running. So we'll keep it like this only and we'll open one new session just to check whether we can run the commands or not. Okay, so background these tasks are running. Okay, so this installation is still running. Okay, so sudo su hyphen. Okay, we'll check kubectl get nodes. Current server was refused due to use PC by the right host or port. Okay, so I think it is still is running. Mm-hmm. Okay, this one is active. Okay, CTL version. Okay, so look, diffusion. Mm-hmm. Okay, keep CTL version. Okay, I think we should run that. Mm-hmm. Okay, so let's. Okay, that context I think we need to give. Mm-hmm. Okay. Mm-hmm. So it is still running. Let's shoot it for specify the right host or port. Okay, so I will check for the Kubernetes. I am checking whether that kubectl question installation. Okay, so after create a cluster to update, we need to give this to update my cluster. Okay, let's say I'm not sure whether this will run. Okay, created one managed node group. Okay, so now the installation is completed. Cluster and okay. Mhm. Now try to run that command. kubectl get. See, now you get these nodes. Okay, so before earlier, because it was not the installation was not complete, that is why we were not getting the node status. So this is the command to get the node status, and it is showing in the ready state. Okay, so we have already given that two nodes will be created, right? Okay, so by default it takes the two node. Okay, and it is of the T2 small category, that is. Okay, so these are the version, these are the age. So this is the two nodes which is deployed on the AP South 1. So if you check the AP South 1 region over here, you will see the cluster over here, right? This is my cluster. Okay, so my cluster nodes. So let's go to EC2 in the AP South 1, and here you can see the instances running are 2, right? So these are the two worker nodes that are being created. So whatever these worker nodes, okay. So by default, two worker nodes are created. So this is my worker nodes, and this is my cluster, which I have already shown you. Okay, this is my cluster, the control plane. Okay, so now we can create one pod also. Okay, so just copy this pod. We are creating one nginx pod. Okay, so kind is pod. And this pod will create the container, create the pod of the nginx application. Okay, so just create one vi sample dot yaml file. Okay, paste and lrth. So just give the command kubectl. Now just check before creating the pods. This is the command to check the pods. kubectl get pods. So no resources found, right? So when you, how can you create kubectl apply -f sample.ml file, execute. So we can see that this pod nginx is created. Okay, so just check the now the status of the pod. So this pod is running, right? This pod is created and it is ready, this nginx one. Okay, so this way you can check the status of the pod, whether it is running or not, whether it is restarted or not. Okay, so this is the way to create the pod and nodes and the cluster. Okay, so I hope this is very clear to you. Okay, and how can we delete the cluster now? This is the command, right? Just copy here and just change the name over there. So by deletion, it will also take the 15 minutes. Okay, so make sure you delete your cluster if you are practicing it. Otherwise, you will get the bills. So this will delete the cluster from the AP South one, and it will also delete the worker nodes over here. Oh, sorry, the in the EC2 in the AP South one region. Okay, so this will also be getting deleted. Okay, so if you take this public IP and check the nginx